Alright guys, some of you are still confused on how to figure out things like the acceleration and how far an object dropped. So, in our first experiment, I had you guys go out and observe how things fell, and you saw that they speeded up. But I also said in that first video, you're going to have to go all the way back and do things like graphing. And right here, we're going to do a velocity versus time graph, VT. Anyways, this is a speed of 0. If you look, and this is, say, a speed of 3 feet per second, and it goes at a constant speed, that's what your velocity time graph, 3 feet per second forward. Okay, if that went on for, say, 10 seconds, well, you guys, and this is how I taught you to kind of build from these graphs and use your prior knowledge. Doing head math, you know, going 3 feet per second for 10 seconds is going to take you 30 feet. At the same time, we figured out that that's the same as the area of this box. The height is 3, the width is 10. 3 times 10 is equal to 30 feet. So we figured that out using what we know to solve what we don't. Now what we're going to do is, like I said, in that experiment, we saw that when we dropped objects, we saw that they sped up. They sped up at a constant rate. So you guys had learned also that a velocity time graph that's, say, speeding up, and in this case it's speeding up in a downward direction. I don't want to mess with you too much right now. I would draw that one going down like that, but for the sake of explaining this, I'm just going to say it was an object speeding up. You guys, however, did not know in your first objects what their speed was. You did know that its initial speed was right here at 0. This, you don't know. However, you guys did take times and use your stopwatches, and let's just say it took something 3 seconds. Let's just say it took something 3 seconds to fall. That's the end of your triangle. And you knew the height of your triangle because that's the height that you dropped it from. Let's just say you dropped it from 10 feet. That means the area underneath that triangle is going to be 10, which means that the area of this box would be 20. Okay, so if I know that the area of the whole box is 20 and the width of it is 3, the height of this would need to be 20 divided by 3. I should have done a better number, huh? Let's make this it took 4 seconds. There we go, improvise. So if it took 4 seconds to fall 10 feet, we know that the area of the box would have to be 20, so this width would need to be 5. 4 times 5 equals 20, and then we took half of the box, so 20 over 2 equals 10. So this was the height that you guys dropped from. This was how long you timed it to be. From those two numbers, you could figure out what the end velocity was. Final velocity. That's how you solve that one. So now in the same scenario, some people are like, well, okay, I found my final velocity, but what the heck does that matter? Well, now you need to figure out the acceleration. It went, and we said that acceleration is how much something's speed changes by over a period of time. Well, how much did its speed change by? It went from 0 right here to 5 right here, so it changed by a speed of 5 over a period of 4 seconds. So we did 5 minus 0 is equal to 5 over 4, which is equal to 1.25 feet per second per second. That's how you would find the acceleration. So some of you were still rather confused on that. And that's what you needed to do actually in Falling Apples Project 2. I said, what is the acceleration of those objects? That's what you needed to do. You needed to use your height and everything like that. In Project 1, you needed to see that they were changing speeds, so that would have gave you a graph like that. In any case, I'm going to shrink that and move it over here. You had to do the trajectory of 0, and once again that forced you to calculate the acceleration, so you should have done it then. But for the last problem, the one that you guys had to do with the cliff face, and this is, I'm going to go like this, here's our cliff face. So now we've got this knowledge that we've gained, and once again I should be drawing this line going diagonally downward, but I'm not going to. We know that the trajectory, the speed going downwards, initially was 0. Then you guys used your stopwatches, and you had already determined by launching your own golf balls with the trajectory of 0 that, well, that object that's launched, and obviously the speed that we launched it with depended on it. The faster you launch the golf ball, the slower it actually falls. One of the reasons is it's going to hit a whole lot more molecules and skip along the top of them like a skipping stone. So that's why I said picture skipping a rock. If you throw that rock, nice little flat rock, and you throw it that way, it's going to skip all across the water. So it's going to go like this and like this, and eventually that water will slow it down enough that the rock will stop and sink in the water. This is what's going on with our golf ball and the air molecules. One of the things that's happening. In any case, you were to come up with some sort of acceleration from your Falling Apples project number 3 for that golf ball. Let's just say that the acceleration you came up with was 30 feet per second. So we're going to say our acceleration you determined was 30 feet per second per second. Alright, and then we had a time, and you were to watch the video, and let's just say that that time was 4 seconds. Well, I know that my graph is going to end at 4 seconds. What I need to do is now figure out, well, an area for a triangle, but I have to make that triangle. That area of the triangle will be the height of the cliff. If this is going 30 feet per second for 4 seconds, that means that at 1 second, its speed is 30. At 2 seconds, its speed is 60. At 3 seconds, it will be 90. And at 4 seconds, it will be 120. So, here we go, something like that. So we're going to have this straight line along there. Starting to see your triangle, hopefully. So I know that the height of that now is 120. The width is 4. So the area of this whole box would be 4 times 120. If I did 4 times 120, I get 400 plus 80 is 480. That's the whole thing. 480. But that's not the height of my cliff. The height of my cliff is half of that. So 480 over 2 will give me 240. So the height of that cliff was approximately 240 feet. I hope that helps. I'm going to explain the other one in another video.